All right, good afternoon, grade nines. I hope that you guys are all having a productive Tuesday so far, and that your week is treating you all right thus far as well. Guys, we're going to get started with our lesson pretty shortly. I just want to give everybody an opportunity to join us like I usually would. So I would really appreciate it if you could just be patient with me for 1 or 2 more minutes just to give them a chance to join. In the meanwhile, you guys are more than welcome to grab everything that you need if you don't have it already. Yes, that does include a calculator, so please have it. Guys, today we're not going through anything crazy, but we are going to discuss some of the fundamentals that we need to understand for the world of geometry. Specifically, we want to go down a little bit of a rabbit hole and discuss why we need to understand the theorem of Pythagoras. Right? This is something that you guys have probably learned about this year. If you did learn about it last year, that's awesome. But we do need to make sure that we understand it thoroughly. Now, a lot of you might be sitting there and thinking to yourselves, so why in the world, out of all of the topics we could go through, would we discuss the theorem of Pythagoras? And the reason that we want to go through it today, guys, is because number one, it's setting us up for future lessons because we're heading in a very specific direction with all of our classes. But number two, it's one of those small skill sets that you need to have when it comes to the tool belt that you have for maths, right? I need to be able to complete certain things like work with fractions and work with decimals and so on and so forth. And Pythagoras is just another one of those things. We've obviously recently spent some time discussing area, perimeter, surface area, and volume of different shapes, right? So we have been going through a little bit of geometry. Yes, that was a little bit of 3D geometry to some degree, but we want to dive into the specifics of Pythagoras. Okay, I understand that this lesson might not be for absolutely everybody, but if I were you guys, I'd stick around just to make sure you know everything that there is to know about it. And then we'll obviously move on to new work again next week. Okay. Please keep in mind, I will ask this only once and I'll maybe remind you at the end of the lesson. If there is a specific section of work that you would like for us to cover now within the next few weeks, especially as we're heading into exam season, please type a message into the comment box naming the specific topic that you want to go through. Okay. Sorry, guys. I'll then use this at a later stage to help you guys by maybe spending a session answering everybody's questions or something in that fashion. I haven't quite decided yet. But again, if there's stuff you want me to go through that's specific to you, please type it into the comment box for me and I'll see if we can get to it before you guys write exams. Okay, now I'm going to start by quickly sharing my screen with you guys. You can write down today's date, which is the 13th of May in the meanwhile. And our heading is going to be the theorem of Pythagoras. Okay. Now, I believe that some of you might already have a foundational understanding of this topic, so I'm not going to explain every small basic concept in immense detail. I am going to try and keep up the pace so that you guys don't get too bored. All right. With that being said, guys, you should be able to see me scribbling in white, yellow, orange, and even green. Okay, if at any point during the lesson you cannot hear what I am saying or see what I'm writing, you need to please type a message into the comment box for me so that I can then try and fix that issue as soon as possible. All right, guys. So let's go ahead and start with today's work. Like I said, we're going to be talking about the theorem of Pythagoras. I'm going to start by writing down some of the basic information that we need to know, right? Some of the theory, and then we will dive into some more details. Right, the theorem of Pythagoras. Again, you guys can write down the date if you want to. So let's start at the very beginning. What exactly are we talking about when we discuss the theorem of Pythagoras, guys? Well, first things first, let's write down a few bits of important information, like I said. Number one, this theorem stated mathematically is the following. We would say AC squared is equal to AB squared plus BC squared. All right. Number two, what else do we need to know about the theorem of Pythagoras? This theorem only works with right-angled triangles, guys. You may not use these on isosceles triangles, equilateral triangles, scalene triangles. None of those will work. Only right-angled triangles. Now, when it comes to actually using this theorem, what do we actually need to have in order to be able to use the theorem? You must have at least two sides lengths to apply the theorem. So if I only have one side of a triangle, that's not going to work. It does not help me. I need to have at least two sides of a triangle in order to apply the theorem. Now, I'm going to come back to this in a second, but I want us to take a moment to quickly take a look at a right-angled triangle, because there are a few misconceptions about all of the labeling conventions that we use when it comes to working with triangles. So let's discuss this very quickly. If I have a right-angled triangle over here, every triangle will have three corners that will be labeled uniquely. So let's say, for the sake of this example, we picked A, B, and C. We're not very creative as mathematicians, guys. What I need you to be clearly aware of is two things. We have got three sides and three angles. Now, the three sides of a triangle may go by different names. So what I'm going to quickly do is take this triangle and make a second copy. Why would I want to do that? Well, looking at the left-hand triangle, we can see that the side over here, sloping downwards, stretches between corner A and corner C. So we could call this side AC, right? That's no surprise, guys. The bottom would be side BC, and this side would be AB over here. Now, if you choose to read it in a different order, that's okay, but we like to write letters down in alphabetical order. What you might not know is if I look at angle B over here in my second triangle, and I then look at the side opposite this angle, this would be considered or could be named side B, but now it would be a lowercase letter. If we look at the side opposite to angle A, we could find side A, right? And the same is true for the third side of my triangle, or the third angle. If I look at angle C and I identify the side opposite from that, we have side C. And all of these will be written with lowercase letters. Now, why do I tell you this? When we look at textbooks and we try and study this section of work, sometimes when we go through other sections of geometry, these naming conventions can be a little bit confusing. Sorry, guys. The naming conventions can be a little bit confusing, but different textbooks are going to use different conventions. So let's talk about what the theorem of Pythagoras is. I'm going to make one more copy of a triangle. You do not need to copy this. Okay, just watch what I'm doing at the bottom of the screen very quickly. When we talk about Pythagoras, it's very, very simple. The theorem itself essentially tells us that the longest side of the triangle over here is always going to be opposite our right angle, right? And this has been given the unique name of the hypotenuse. Okay, the longest side of the triangle will always be opposite the right angle, and it's called our hypotenuse. You can abbreviate that with HYP if you so please. Just for your notes, not in a test or an exam, right? So, what is so unique about this hypotenuse, this longest side of the triangle? Well, it's special to us because if we take the two remaining sides, let's say this side has a length of x and this has a length of y. If we square these two values and add them together, we essentially get the length of our hypotenuse. So, what is this whole concept of the theorem of Pythagoras really for? It helps us to solve the missing length on a triangle, right? Now remember, earlier on I said to you that you must have at least two sides lengths to apply the theorem. So only when there is one missing length on our triangle, and it is specifically a right angled triangle, are we able to use the theorem of Pythagoras. So let's write this down, and then I'll explain it in a bit more detail as we progress into our examples. Looking at our triangle on the left over here, the hypotenuse is this really long side over here, right? Side AC. So we would say side AC squared is equal to, and you can list either of the other two sides first. Let's say we worked with AB first. AB squared plus the third side of the triangle, BC squared. Right, so AC squared, this longer side of our triangle, is equal to the sum of the square of the two shorter sides. Right, and there we go. That's the theorem of Pythagoras for this specific triangle. Right, now the letters can change, but the concept does not. The longest side of the triangle is equal to the square of the two shorter sides of the triangle. Now, I have a second triangle over here where we have a slightly different naming convention. And this is where the different, the alternate version of the theorem comes from. The longest side of my triangle is B over here, right? The hypotenuse. So we would say that side B squared is equal to the shorter side over here on the left, C squared plus A squared. It could be the other way around. If you wanted to write it as A squared plus C squared, that's completely okay. But what this does for us is it shows us the two possible variations of the theorem that we could bump into. They mean exactly the same thing, but it's just that they have different writing styles. Okay, now I've just told you that the theorem of Pythagoras can be used to solve the length of any missing side on the triangle, right? Any missing side, as long as we have the other two. So if we were to just quickly think about a right-angled triangle, while the standard form of Pythagoras helps us to find this hypotenuse over here, we can also use Pythagoras to help us find the height of a right-angled triangle or the base of the right-angled triangle, right? So looking at these three different colors over here that we have on the triangle, this suggests to us that we could have three different variations. And again, I'm going to label this side over here AC, right? We know that the bottom is BC and the left-hand side is AB. Right, we still have the same sides as we did over here. And actually looking at these two triangles, guys, I'm going to change the color of this text. I know you might not be able to, but maybe you can highlight it or something like that. I'm going to change the color of these sides. Now, why am I doing that? Because as we begin to reformat the equation that we have identified so far, we can find the variations that we use to find the lengths of the missing sides, right? So we know that this longest side is B over here, this base is A, and the far left-hand wall is C. So now that we have a few colors involved in the situation, let's rearrange the formulas that we already have. AC was the yellow side over here, right? But I can also rearrange this to say that AB squared is equal to BC squared, or sorry, AC squared minus BC squared, right? All we've done is rearrange this. Now, pay close attention to the fact that my sign has changed, but so has the focus of my formula. And I can do the same once more. I can say that BC squared is equal to AC squared minus AB squared. And again, this gives us the third side of the triangle as the focus of our equation, the subject of the equation. So if you have looked in your textbook at sections about the theorem of Pythagoras and seen variations like this, it's not because it's there to confuse you or it's overly complicated. It's there because they are all rearrangements of one another, right? It's just our original, which we have at the top over here, being reorganized so that we can solve for the different sides of a triangle. And we can take this version that we have on the right over here with the lowercase letters and do exactly the same thing, right? We can rearrange this. So we would then have c squared is equal to b squared minus a squared. And again, guys, I'm showing you where these variations come from so that you're not confused by them. Okay, so there we go. Those are the two styles of the Pythagoras theorem in their three different versions. Okay. So using this equation, guys, you can really memorize one of the first two, right? You can memorize this one over here or this one over here. As a matter of fact, as long as you memorize that the longest side of the triangle is equal to the sum of the two shorter ends of the triangle, then you can derive the equation on your own. But you also now have all of this information in case you do choose to study it. So now we're sitting here and we have 6 different equations and everything seems really, really confusing, but we now need to apply this to examples so that everything makes a little bit more sense to you guys, right? So I'm going to give you an opportunity to quickly finish copying, and then I'm going to move on to some examples. If you guys have any questions, please make sure that you ask me now quickly. Right, guys, somebody's asked if this is for term 3 or for term 2. I apologize for not responding to your questions sooner. Sometimes they take a little bit of time to come through. Guys, this is actually considered term 1 work for grade 9. If you guys have not learned this in term 1, then it's term 2 work. Okay. If your teacher only covers it in term 3, I suppose that is up to them in the end, but this is generally learned in the first half of grade 9 and in some schools even in grade 8. Okay, which is why I'm going over it for you guys. So let's go ahead and take a look at some examples. If you guys need me to come back up so that you can finish copying, please let me know. I'm going to go through 3 examples with you guys and then just give you a little bit of extra information at the end. And that will be it for today. We are already just short of halfway through the lesson, guys. So if you do have questions, please make sure that you ask. Your time is running out. So let's take a look at an example of a triangle over here, and let's not complicate this so much. All of this extra information and rearranging and all of this work has made things a little confusing for some of you, I'm sure. So let's take a step back and simplify it all. I am given a right-angled triangle over here. This is example number 1. Next to examples, the question is going to be find the length of the missing side. Find the length of the missing side. Okay, let's say in this first example here we have triangle DEF, and we know that this side is 4 units long, while the base of the triangle is 5 units long. I am being asked to identify the length of the missing side, and I am specifically informed by the diagram that this is a right angle triangle. How do I solve this question, guys? Remember, The side opposite from my right angle is called the hypotenuse. It is always the longest side of a triangle. Right. So, how do I start this off? We can either memorize Pythagoras or we can sort of create it as we go, which I would recommend. Remember, this is my makeshift right angled, triangle over here. The side opposite from the right angle is the hypotenuse, the longest side of the triangle. Pythagoras tells us that this side of the triangle squared must be equal to this side squared plus this side squared. So we know we need to start with the hypotenuse, side DE, right? So we're going to say the following. DE squared must be equal to these two sides added together, right? So DF is the left-hand side, that's the really short side. DF squared plus EF squared. The longest side, the hypotenuse DE, is the same as DF squared plus EF squared, right? That is Pythagoras. It's as simple as that, guys. So I know that I'm looking for the length of DE squared, so I'm going to leave it as is. DF has a value of 4 units and EF has a value of 5 units. So we will square the value 4 and the value 5. Now, for those of you that don't have a calculator, I'll write this information out, but please make sure you try and bring a calculator to the next lesson if you can. 4 squared is equal to 16 and 5 squared is equal to 25. Again, you may use your calculator for this if you wish. So DE squared is going to be a total of sorry guys, just a second. Okay, well, so be it. 16 plus 25 is going to give us 41. Right? Now, we do not want DE squared. We just want the length of DE on its own. So, in order to get rid of the square symbol, we're going to use the inverse, which is to square root both sides of the equation. Okay, on the left hand side, the square root symbol and the square symbol will cancel, leaving us with just the value DE. And on the right hand side, the square root of 41 you would need to use your calculator for. And you see, when you round off to 2 decimal places, you get 6.40 units. Right. So there is then your final answer. You found the length of the missing side. Does it make sense that this longest side of the triangle is 6.4 units? Yes, it does, because it's quite literally the longest side of the triangle. Okay, I hope that calculation made sense. Right, let's go over to a second example. Example number 2. I'm going to copy this triangle over here, but we will use different information. Okay, let's go ahead and work on our second triangle, guys. Triangle number 2, we are given the following information. We are told, if you guys need me to go back up, please do let me know, all right? But I'm just going to add information onto question number 2 for now. We are told that our triangle LMN has the following measurements. The left-hand side of the triangle is a total of 6 units. The base of the triangle has a length of 8 units, and we are looking for the length of the final side. Right. So again, we run into another question where we are being asked to solve for the missing side of a triangle. Remember, the side opposite your right angle is called the hypotenuse, and it is the longest side of the triangle. It's always our starting point for our sort of theorem that we write down, right? So again, guys, very quickly, think about a triangle. Here's my right angle triangle. We know that the longest side over here, the hypotenuse, is always going to be the shorter sides added together, right? So what does that tell us? Side LM, this longest side of the triangle, LM squared must be equal to the shorter side squared added together. So the short left-hand side, or the height of the triangle, is side LN. So it'll be LN squared plus MN squared, the base of my triangle. Right? Okay. Apologies, grade 9s. My electricity has just gone off, so please just give me 1 second to quickly use a battery to make sure we can keep our lesson going. But I would like for you guys to please try and complete this question. See how far you can make it. We know that the longest side LM is equal to the 2 shorter sides added together. So because we are solving for LM squared, leave it on its own and substitute in the remaining values, please. Okay, see if you guys can get to an answer. I'll give you 2 minutes and then we'll go through it together. Right, apologies for the noise, guys. I hope that you've made some progress on trying to solve this question. So let's quickly take a look. You'll just have to excuse my camera for now, guys. As long as you can still hear me, all should be good. So looking at example number 2, triangle LMN, we know that side LN on the left over here, the height of the triangle is 6 units, so we can square that. And we know that the base side MN is 8 units, which we can also square. For those of you that don't have your calculators, 36 squared, 6 squared is 36, and 8 squared is 64. So LM squared, the hypotenuse of our triangle, has a total length of 100. Well, LM squared, right, has a length of 100 units, but we are not looking at LM squared. So in order to get rid of the square symbol, we would need to square root both sides of the equation, both the left and the right. And once we've done this, we know that on the left-hand side, we will be left with only LM, and on the right, the square root of 100 is 10 units. So the answer to question number 2 is 10 units of length. And if we were to say that this side, the missing side of our triangle, has a length of 10 units, would that make sense? It absolutely would, guys. Remember, the hypotenuse has to be the longest side of the triangle no matter what. So the fact that it is the longest side by length confirms that we are probably on the right track. Right, so there we go. That's example number 2, guys. So that's not exactly super tricky. I hope that that makes sense to all of you. And we've got about 20 minutes left of today's lesson. And so what I want to quickly show you is how we solve questions like this when we need to use Pythagoras to solve for one of the other sides of a triangle, right? Not the hypotenuse. And this goes back to what we discussed earlier when we made the 3 variations of each style of the theorem. Okay, so I'm going to give you again a few seconds to quickly copy what's on the screen over here while I draw up example number 3. Guys, we have 2 more examples left today, and then I just want to point out some interesting bits of information to you, and then we will be done. Okay, so I hope that you will stick around, and if you do have questions, I hope that you will ask them. But let's go ahead and draw our triangle for example number 3. So that we can fill in the missing information, or well, fill in our known information so that we can find the missing information. Okay. Let's say we were working with triangle XYZ for example number 3. And we were told that we have sides of the following length. 13 units over here, and 12 units along the base of the triangle. We are being asked to figure out the length of the height of the triangle, the third side. I'll give you guys a few more seconds to quickly finish copying example number 2, and then we're going to dive into example number 3. So, like I said to you guys at the beginning of the lesson, it's important to remember that we can use Pythagoras to solve for any missing side on a triangle, on a right angle triangle, as long as we have 2 of the other sides. Okay, so let's think about example number 3. I assume you guys have had enough time to copy. If you need more, you know what to do. Please just message me in the comment box. Okay, so example number 3, guys. Let's take a look. Again, just please keep in mind, Pythagoras is always in the standard form, going to tell us that the hypotenuse, the longest side over here, is equal to the sum of the 2 shorter sides, right? So with that being said, before you try and automatically solve for the third side, write the theorem out in its standard form. So the hypotenuse, we can see, is quite clearly this side over here, side xy. So we will say xy squared is equal to xz squared plus yz squared. Okay. Now, in this case, you have 2 options. You may either reorganize this first, or you substitute in your values and reorganize later on. I'm going to do one example of each. In this case, we are looking for the side xz squared. So to get that on its own, I would need to move yz over to this side, right? And we would have xy squared minus yz squared is equal to xz squared, which is the value that we are interested in, right? Now we may go ahead and switch the sides of the equation around so that it's easier to read. So xz squared on the left, with everything that we had on the left now on the right. Okay, this is how we would rearrange this. So to start solving, we use our rearranged equation. Xz squared is equal to xy squared minus yz squared. I know that listening to the letters can be a bit confusing, but the left-hand height of this triangle is what we are solving for. So this remains the focal point or the subject of our formula. Xy is the hypotenuse, which is 13 units squared, minus the base, which is 12 units squared. Again, you can use this. Complete this sum in your calculator, but for those that don't have a calculator, 13 squared is 169, while 12 squared is 144. So xz squared then has a value of 25 units, but we do not want xz squared, so we will go ahead and square root both sides of the equation so that xz as a length on its own has a value of 5 units. Okay, and yes, that's absolutely correct. In the context of our triangle grade 9s, does it make sense? Well, if I were to replace the question mark over here on our triangle with a 5, yes, it does make sense, right? It's shorter than the other 2 sides, but it's still a very realistic number to have in this scenario. All right. So XZ is 5 units. Please take note of the fact over here we have two separate parts. This is rearranging the formula or the theorem actually. And on the left-hand side, we have the substitution. As far as your marks are concerned, guys, it'll probably be a mixture of these two, but the information over here on the left does carry more value. Okay. Right, we have one last example, guys, to do, but I'll give you an opportunity to copy. Now, in case there are any of you that have noted something I've done over here, I have said that xz squared is equal to 25, and I've gone and square rooted both sides. When I do this, some of you might already know that I should have a plus or minus in front of my 25, and then confirm that the answer is, oh, sorry, not 25, just positive 5. Okay, some of you might already know of this plus and minus feature. And yes, you should apply this in algebra, but for the sake of the theorem of Pythagoras, we don't need to follow this step over here, or at least not stated explicitly. Okay, so you guys have got the answer for number 3. Quickly copy. I'm going to give you 1 minute and move on to example number 4, the last example where we solve for the third remaining side of this triangle. All right. I'll leave the calculation on the screen there for you guys. For those of you that are done, let's quickly go ahead and copy down the third and or fourth example for the night, and then we will be done, guys. Please keep in mind, I mentioned this earlier, but for those of you that were not here, I know that many of you have specific topics that you would like to cover in the coming weeks, especially as we begin to prepare for exams. If there are specific topics that you would like for us to go through, please type the name of that topic into the comment box for me. Okay. Right. Our third and final triangle, grade 9s. We are told that the left-hand side is 9 units. The hypotenuse is 15 units. But we need to find the remaining side over here at the base of the triangle. Okay, this triangle we can label QRS, triangle QRS. Now, this time around, I'm going to show you how we can still solve this, but without doing all of this rearranging right in the beginning, right? In example number 3, we rearranged the formula or the theorem first, and then we substituted. We actually don't have to do that. So I'll just show you what that looks like if you choose to follow this sort of style. We know that the longest side of the triangle is the hypotenuse, and it's always equal to the sum of the two shorter sides. So in the context of this triangle, side QR squared, right? QR is this side over here. The hypotenuse is going to be equal to QS squared plus RS squared. Okay. Now, instead of going and rearranging this now already at the beginning, we can automatically substitute. So QR squared is the hypotenuse, which has a length of 15 units. QS has a length of 9 units, and this is the height of the triangle. And finally, RS is what we want on its own, right? We're looking for RS squared. So if you want to highlight it or write it in a different color so that you can remember what you are solving for, that is completely fine. Now, how do I solve this? Well, we start with the value of 15 squared, which gives us 225. So we have 225 on the left, 9 squared gives us 81, and we need to add on this RS squared. Now, in order to get RS on its own, it means I'm going to have to move this 81 over to the other side. And when I do that, the sign must change. So on the left, we're going to have 225 minus 81 is equal to RS squared. 225 minus 81 gives us 144 on the left-hand side, equal to RS squared. But we know that we want to have RS on its own. So again, we can square root both sides of the equation. Okay, so the 12 units is the answer. 12 units is equal to RS. And you can obviously switch this around, guys, as long as you keep everything the same. RS is equal to 12 units. Right, now thinking about the value over here that we've just gotten, 12, does this make sense in the context of our triangle? Yes, it does, because it's, similar to the other sizes or the other lengths that we have, but it's still shorter than the hypotenuse. Somebody is asking what we are busy doing, grade 9s. This topic is called the theorem of Pythagoras. It falls under a small section within geometry, grade 9s. Oh, sorry, guys. Okay, it falls under the chapter of geometry because we use this to solve missing lengths when we are working in geometry. All right. So I hope that example number 4 has made some sense to you guys, and that this whole concept of the theorem of Pythagoras makes a fair amount of sense. Which curriculum is this, guys? It should be in every curriculum. Depending on which curriculum you're following, you could be learning it at different times. Now at the end of grade 8 versus the beginning of grade 9. But this is included in the IEB curriculum, the not NSC, sorry guys, I've forgotten some of the curriculum names all of a sudden. I'll answer the question now. Right, it's included in IEB. It's also included in CAPS. You should absolutely learn it if you are also in Cambridge. I cannot speak for when exactly the topic is taught in each curriculum, but these are the 3 major ones that we really use in South Africa. Right, somebody has quickly asked if they were allowed to work on this step a little bit differently over here. And first, bring the 9 squared across so that they had 15 squared minus 9 squared. Yes, that's absolutely fine. Just remember that it's equal to RS squared, not just RS. Okay, I hope that answers your question though. So guys, this is something pretty much everybody needs to know. This is not specific to some kind of curriculum. If you're really, really nervous that you aren't going to be covering it in your section of work, you're more than welcome to speak to your teacher about it. They will have all of the information. Okay, but I know for an absolute fact that it will be covered in these 3 syllabi. So if you are in one of these curriculums or a part of one of them, then yes, you will need to know it by the end of grade 9 at the absolute latest. All right, so guys, that's pretty much it for today's lesson. We're actually out of time for today. I've just realized that it's now 6:30. I want to quickly take a second to show you guys where you can access quizzes to do with the theorem of Pythagoras on the iRainbow platform, right? I know that many of you are probably quite well versed with the platform, but if you guys would like to stick around for 1 or 2 more minutes to quickly allow me to show you where the quiz is, then I think that would be great so that you guys can study. But we are officially done with the learning. So if you guys are in an absolute rush, then you are more than welcome to leave. Okay, so I'm just changing my screens very quickly. Excuse the lighting, guys. I know that this is far from perfect, but it's just a solution for now so that you guys still have your lesson. But let's quickly go and take a look at iRainbow. Okay, so sorry about that, guys. When we go into grade 9 on iRainbow, your guys' layout should look pretty similar to mine. It shouldn't look all that different, but as we go into the software, we can go ahead and click on the topic of measurement over here at the bottom right, and then immediately you'll see a subtopic pop up, which is called the theorem of Pythagoras, right? So we can click on the theorem of Pythagoras, and then under that section, you will see that there's actually quite a few subtopics that come out of that, okay? I would recommend that you guys go ahead and try all of these quizzes. They are not hard, guys. They really are not. But I would recommend using the information that I've given you today to help you find the answer to these questions. And as you go through each one, you can see here that this is under the grade 9 section. Yet the very first quiz is called Theorem of Pythagoras Revision. Okay, that just sort of re-emphasizes the fact that this is something that you guys should have touched on briefly already. But when you click on the quizzes, you guys will be given access. Sorry, guys. You will be given access to PDF documents that go and explain all of the work that we've just done in an equivalent amount of depth, but it also goes through some examples. You can then progress onto the questions where you need to answer a variety of different questions. We didn't get to cover everything today, guys, but we definitely covered a huge majority of it. So if you can take the time to work through each of these quizzes one by one over the next 1 or 2 days, I think that you would put yourself in a really good position. Okay, a lot of them will have these PDFs that you can go and read and spend a little bit of time understanding. But beyond that, guys, it's really just going to take a little bit of practice from your side. Okay, there are probably 4 or 5 different PDFs reiterating everything that we've spoken about today. And as you go through these questions, please make sure that you try and solve them on a piece of paper. because the software only accepts the answer itself and not all of your working out for obvious reasons. All right. When you're done with the quizzes, you can go to the reports tab on the left-hand side and get a breakdown of all of the quizzes that you did. You can understand how long it took you to complete the quiz and what kind of results you got. And this will just be really helpful for calibrating your studying, right? It'll help you to understand what you specifically need to focus on as you move into your exam seasons. Okay, so guys, this is unfortunately now, outside of our lesson time, but I really hope that you will take the time out of your day to go and try and use this platform. There's a reason that I'm recommending it. I have used it. I have helped create a lot of the videos for different grades that are found on that platform. So I really do know that it is worth your time. All right, guys, that is it for today. I just want to quickly check for any remaining questions. If you guys need to copy, please let me know if you need me to bring my screen back up. Okay, I just want to make sure I answer everybody's questions. Sorry, guys. Okay, somebody's asked if I'm familiar with the CBSE curriculum. I know of it, and there are certain schools that I have worked alongside that have used this curriculum, but I unfortunately don't know the curriculum in enough depth to tell you when exactly you would be learning this topic, the theorem of Pythagoras, or even if you do cover it. But I know that if you want to be able to write your NSC final exams at the end of grade 12, this is something you are going to need to know. All right. I've taught so many students from so many different curricula that it's quite crazy. But if you would like, you're more than welcome to send me a message about this curriculum if you have more questions, and I can try and find some answers for you. Otherwise, you can always chat to your teacher, and if there's anything you want to then come and talk to me about, you're more than welcome to do that. All right. I hope that answers your question. Guys, that looks like those are pretty much all the questions for today. So we are done for today. Our next lesson is going to be next week, Tuesday, again from 5:30 to 6:30 in the evening. Should there be any change to the times or dates on which your lesson is happening, you guys will find out first thing on Monday morning when I put a message onto the announcements or onto the broadcast channel for iRainbow. Do we have any more questions before I wrap up for today, guys? For those of you that are happy, you're more than welcome to leave. Thank you so much for attending, guys. I hope that there was some value that you derived from today's lesson. For those of you that have questions, you've got 1 or 2 minutes. I'll stick around to answer them. Otherwise, you guys are more than welcome to go. Please just keep in mind that you can watch the recordings of this lesson either on the Facebook page or on the YouTube channel, okay? And you can actually go and find quite a catalog of recordings for other topics that we've done for grade 9 as well, if you want to use that as part of your revision. All right. Okay, guys, I haven't seen any new questions just yet, so I'm going to assume that everyone's okay. So with that being said, if you guys do find more questions, or you think, think of topics that you would like for us to cover in the coming weeks before your exams, please make sure that you bring that information with you to the beginning of next week's lesson, okay? Tell me right at the beginning so that I can help you as soon as possible. All right. Nonetheless, grade 9s, thank you so much for this evening, guys. I wish you the absolute best for the rest of your week ahead and any tests that you might have. I will speak to you guys all again next week. Tuesday from 5:30 to 6:30. If you have any questions, you guys know how to reach me. I'll do my best to respond to you as soon as possible. All right. Thank you so much, guys. Enjoy the rest of your evenings.